Hello students, welcome back to this lecture, One Coordinate Geometry. So in this lecture, basically we'll discuss examples, one distance formula. So, so in our previous lecture, we have started introduction and then we discussed distance formula and we also solve some examples. Okay, so in this lecture, basically we'll also discuss some examples, one distance formula. Okay, so let us see this example. So in this example, here figures in this figure shows the arrangement of desks in a classroom. Okay, so Asima, Bharti, Kamela are seated at A point 3, 1, B point C, 4, and C point 8, 6. Okay, so here Asima, Bharti, and Kamela are seated at this point respectively. And now, do you think they are seated in a line? Okay, so if they are seated in a line, then give reasons for our answer. Okay, so let us see how to solve it. So here basically we will use distance formula. So using distance formula, we have distance AB. AB, this is equal to actually square root of 6 minus 3 whole square plus square root plus 4 minus 1 whole square. Okay, so here the coordinates of A are 3, 1 and the coordinates of B are 6, 4. So the distance AB, this is equal to square root of 6 minus 3 whole square plus 4 minus 1 whole square. Okay, and now here if we calculate it, then you'll get this is equal to square root of 9 plus 9, that is equal to square root of 18, and this is equal to 3 times square root of 2. Okay, and now distance between these 2 points B and C, that is BC, this is equal to square root of 8 minus 6 whole square plus 6 minus 4 whole square. Since the coordinates of B are 6, 4 and the coordinates of C are 8, 6. Okay, so the distance BC, this is equal to square root of 8 minus 6 whole square plus 6 minus 4 whole square, that is equal to square root of 4 plus 4, and this is equal to square root of 8. Okay, and this is equal to 2 times square root of 2. And here the distance AC, this is equal to square root of 8 minus 3 whole square plus 6 minus 1 whole square. Since the coordinates of A are 3, 1 and the coordinates of C are 8, 6. Okay, so the distance AC, this is equal to square root of 8 minus 3 whole square plus 6 minus 1 whole square. And this is equal to square root of 25 plus 25, and this is equal to square root of 50, and this is equal to 5 times root 2. So since here, if we take sum AB and BC, okay, so AB plus BC, this is equal to 3 times root 2 plus 2 times root 2. And this is equal to actually 5 times root 2, that is actually length of AC. Okay, so we can say that the points A, B and C are collinear. Since if we add AB and BC, then we get AC. Okay, so AB and C, these 3 points are actually collinear points. Therefore, they are seated in a line. Collinear means they are seated in a line. Okay. So in this example here, we have to find a relation between X and Y such that the point X, Y is equidistant from the point 6, 7, 1 and 3, 5. Okay. So here we have to find a relation between X and Y. So let us solve this example. So here in this example, first we let P of X, Y be equidistant from the point A 7, 1 and B 3, 5. Okay, so we are given here AP, this is equal to BP. Okay, and so AP square is equal to BP square, and here the distance AP is basically equal to square root of X minus 7 square plus Y minus 1 whole square. Okay, and the distance BP is equal to square root of X minus 3 whole square plus Y minus 5 whole square. Okay, and here we take squaring. squaring both sides, so we get this equation x minus 7 whole square plus y minus 1 whole square. This is equal to x minus 3 whole square plus y minus 5 whole square. That is, if we now use the identity x minus y whole square, that is equal to x square minus 2xy plus y square. Okay, so now we can expand x minus 7 whole square, y minus 1 whole square, x minus 3 whole square, and y minus 5 whole square. Okay, so if we expand them, then we get this simplified equation. So here you can expand them. So x square plus 49 minus 14x plus y square minus 2y plus 1. This is equal to x square minus 6x plus 9 plus y square minus 10y plus 25. Okay, so here x square cancel, y square cancel, and if we simplify them, then we get 50 minus 14x minus 2y. This is equal to 34 minus 6x minus 10y. Okay, and it implies minus 6x plus 14x minus 10y plus 2y. This is equal to 50 minus 34, and this implies 8x minus 8y. This is equal to 16, and it implies x minus y. This is equal to 2. Okay, so if we simplify this equation, then we get this relation x minus 2 is equal to 2. Okay, so which is the required relation. So now here we have given this result. So here we note it down that the graph of the equation x minus y is equal to 2 is a line. Okay, so you can draw the graph of this equation x minus y is equal to 2. Okay, so here for drawing this graph, we need some points on this plane. Okay, so from your early studies, you know that a point which is the equidistance from A and B lies on the perpendicular bisector of AB. So therefore, the graph of this equation x minus y is equal to 2 is the perpendicular bisector of AB. So this is our AB line segment, and here the line x minus y is actually represent this line. Okay, so this is represented by this equation represented by this line, and here you can use your early studies, and here you can say this line actually here from A and B lies on the perpendicular bisector of the AB. Okay, so therefore this graph x minus y is equal to 2 actually is the perpendicular bisector of AB, that is shown in this figure. Okay, so here we will discuss next example. Here in this example, here we have to find a point on the y-axis which is equidistant from the points A 6,5 and B minus 4,3. Okay, so here we know any point on the y-axis actually is out of the form 0, y. Okay, and here we are given from a point on the y-axis which is equidistant from this point A 6,5 and B minus 4,3. Okay, so here we know that a point on the y-axis is of the form 0, y, and so let the point P of 0, y be equidistant from A and B, and then by distance formula, here we get 6 minus 0 square plus 5 minus y whole square. This is equal to minus 4 minus 0 square plus 3 minus y whole square. Okay, and if we simplify this equation, then we get 36 plus 25 plus y square minus 10y. This is equal to 16 plus 9 plus y square minus 6y. And here if we simplify further, then we'll get this equation 4y. This is equal to 36. Okay, and that is y is equal to 9. So we get here the value of y is equal to 9. So So the required point is 0, 9, and you can check. You can let us check our solution here. AP, this is equal to actually square root of 6 minus 0 square plus 5 minus 9 whole square, and this is equal to square root of 36 plus 16, and this is equal to square root of 52. And the distance BP, this is equal to square root of minus 4 minus 0 whole square plus 3 minus 9 whole square, that is equal to square root of 16 plus 36, and this is equal to square root of 52. Okay, so here note it down. Using the remark above, we see that 0, 9 is the intersection of the y-axis and the perpendicular bisector of AB. Okay, so now let us recall the situation in section 7.2. So suppose here a telephone company wants to position a relay tower at P point. P at P between A and B is such a way that the distance of the tower from B is twice its distance from A. Okay, if P lies on AB, then it will divide AB in the ratio 1:2. So here you can see this figure. So here this point P actually lies one OB. Okay, and here this point P divided AB line segment in the ratio 1:2. Okay, so here if we take A as the origin O, okay, and 1 kilometer as 1 unit on both the axes, then the coordinates of B will be 36, 15. And in order to know the position of the tower, we must know the coordinates of P. Okay, and how do we find these coordinates? So here we let the coordinates of P are let the coordinates of P be x, y. Okay, and here draw perpendiculars from P and B to the x-axis, and it mating it in D and E respectively. And here draw PC perpendicular to BE, and then by the angle similarity criteria that we studied in your chapter 6. Okay, so triangle POD and triangle BPC are similar. So basically here we draw these perpendiculars PD and PE on the x-axis. Okay, so here, and we let here the coordinates of P are x, y. Okay, and here this triangle PBC and the triangle APD, POD and BPC, POD and BPC, these two triangles. So these two triangles are actually similar triangles. Why? Their angle by using angle similarity criteria, here we can say these two triangles are similar. Okay, so now therefore their corresponding sides, ratio of their corresponding sides, OD by PC is equal to OP by PB, and this is equal to 1/2, and PD by BC, this is equal to OP by PB, and this is equal to 1/2. Okay, and here we'll so here x by 36 minus x, this is equal to 1/2, and y by 15 minus y, this is equal to 1/2. So these two equations gives us x is equal to 12 and y is equal to 5. Okay, so you can easily solve these two equations, and from this equation you will get the value of x is equal to 12 and y is equal to 5. Okay, so the coordinates of P are 12, 5. So you can check that P of 12, 5 meets the condition that the OP is to PB is equal to 1:2. Okay, and now let us use the understanding that you may have developed through this example to obtain the general formula. So now we will know the general formula. Okay, so here we consider any two points A, x1, y1. So here basically we want to discuss section formula. So here consider any two points A x1 comma y1 and B x2 comma y2, and here assume that P of x comma y divides AB internally in the ratio m1 is to m2. That is PB divided PA divided by PB. This is equal to m1 divided by m2. Okay, so basically here we consider the point A and the point B, and the coordinates of A are x1 comma y1 and the coordinates of B are x2 comma y2, and here we assume the point P as x comma y, and this point P divides AB internally in the ratio m1 is to m2. That means PA by PB is equal to m1 by m2. Okay, so now draw AR, PS and BT. So AR, PS and BT perpendicular to the x-axis, and we draw AQ and BC that are parallel to x-axis. So we draw AQ and BC that are actually parallel to x-axis. And then by the angle similarity criteria, triangle PAQ that is similar to triangle PBC. So PAQ this triangle and this PBC this triangle, actually they are similar to each other. So this triangle and this triangle are actually similar triangle. Okay, so therefore their corresponding sides are in same ratio. So therefore PA by BP is equal to AQ by PC. This is equal to PQ by BC, and naming this equation, this condition as 1. And now AQ, this is actually equal to RS. Okay, and this is equal to OS minus OR, that is equal to X minus X1. And PC, this is equal to ST, that is equal to OT minus OS, that is equal to X2 minus X. And PQ is equal to PS minus QS, that is equal to PS minus AR. This is equal to Y minus Y1. Okay, and BC is equal to BT minus CT, and this is equal to BT minus PS, and this is equal to Y2 minus Y. So AQ is equal to X minus X1, PC is equal to X2 minus X, and PQ is equal to Y minus Y1, and BC is equal to Y2 minus Y. So substituting these values in 1, we get m1 by m2, this is equal to x minus x1 divided by x2 minus x. This is equal to y minus y1 by y2 minus y. Okay, and taking m1 by m2, this is equal to x minus x1 by x2 minus x, and we get the value of x is equal to m1 x2 plus m2 x1 divided by m1 plus m2. Okay, and similarly we taking here m1 by m2, this is equal to y minus y1 divided by y2 minus y, and we get the value of y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. So here we get the value of x equal to m1 x2 plus m2 x1 divided by m1 plus m2, and the value of y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. So the coordinates of the point P are x comma y, which divides the line segment AB, line segment joining the points A x1 comma y1 and the point B x2 comma y2 internally in the ratio m1 is to m2 are m1 x2 plus m1 x2 plus m2 x1 divided by m1 plus m2, comma m1 y2 plus m2 y1 divided by m1 plus m2. Okay, and this is known as the section formula. Okay, so if a point P x comma y divides the line segment AB in the ratio internally in the ratio m1 is to m2, then the coordinates of the point P are m1 x2 plus m2 x1 divided by m1 plus m2, comma m1 y2 plus m2 y1 divided by m1 plus m2, and this is known as section formula. Okay, so now This can also be derived by drawing perpendiculars from A, P, and B on the y-axis and proceeding as above. Okay, so if the ratio in which P divides AB is k:1, then the coordinates of the point P will be k times x2 plus x1 divided by k plus 1, comma k times y2 plus 1 divided plus y1 divided by k plus 1. Okay, so special case, the midpoint of a line segment divides the line segment in the ratio 1:1. Okay, so if we have a line segment, okay, and here the midpoint of this line segment divides the line segment into the ratio 1:1. Okay, so therefore the coordinates of the midpoint P of the join of the points A x1 comma y1 and B x2 comma y2 is 1:x1 plus 1:x2 divided by 1 plus 1, comma 1:y1 plus 1 into y1 plus 1 into y2 divided by 1 plus 1, and this is basically equal to x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So the coordinates of the midpoint of a line segment A P is equal to x1 plus x2 divided by 2, comma y1 plus y1 plus y2 by 2. So now let us solve a few examples based on this section formula. Okay, so let us explore some examples. So here in first example, here you have to find the coordinates of the point which divides the line segment joining the points 4, -3 and 8, 5 in the ratio 3:1 internally. Okay, so we need to find the coordinates of the point. So let us solve this example. So here first we let P of x, y be the required point. Okay, and now if we use the section formula, then we get the value of x is equal to 3:8. 3 into 8 plus 1 into 4 divided by 3 plus 1. This is equal to 7. Okay, and the value of y is equal to 3 into 5 plus 1 into -3 divided by 3 plus 1, and this is equal to 3. Okay, so therefore the coordinates of P are 7, 3. So 7, 3 is the required point. Okay, so now let us see next example. So in this example, so here we have asked in what ratio does the point this -4, 6 divide the line segment joining the points A -6, 10 and B 3, -8. Okay, so here basically you have to find the ratio. So here we will use section formula. So let -4, 6 divide AB internally in the ratio m1:m2. Okay, and using the section formula, then we get -4, 6. This is equal to m1 into 3 minus 6 into 6 into 5 m2 divided by m1 plus m2, comma minus 8 m1 plus 10 m2 divided by m1 plus m2. Okay, and for if we recall, if x, y this is equal to a, b, then it implies x is equal to a and y is equal to b. So now if we use this thing, then we can get to equation. Okay, so we get, so -4 is equal to 3 m1 minus 6 m2 divided by m1 plus m2, and 6 is equal to -8 m1 plus 10 m2 by m1 plus m2. Okay, so now -4 is equal to this gives us this equation, -4 m1 minus 4 m2, this is equal to 3 m1 minus 6 m2, and if we simplify this, then we get this relation 7 m1 is equal to 2 m2. Okay, that is m1 is to m2, this is equal to 2:7. So in 7 is to 2 into 7. So therefore the point 4, -4, 6 divides the line segment joining the points A -6, 10 and the point B 3, -8 divides in the ratio 2:7. So you should verify that the ratio satisfies the y coordinates also. So here now -8 m1 plus 10 m2 by m1 plus m2, this is equal to -8 times m1 by m2 plus 10 divided by m1 by m2 plus 1. Okay, and here the value of m1 by m2 is equal to 2 by 7, and if we put this, then we'll get this is equal to 6. So verify it. Okay, so now alternatively we can solve this way. So the ratio m1 is to m2 can also be written as m1 by m2 is to 1. Okay, so for 1 k is to 1, and let minus 4,6 divide ab internally in the ratio k is to 1, and using the section formula we get minus 4,6. This is equal to 3k minus 6 divided by k plus 1, comma minus 8k plus 10 divided by k plus 1. Okay, now if we use this result, x comma y is equal to a comma b, it implies x equal to a and y equal to b. Then we get minus 4 is equal to 3k minus 6 divided by k plus 1. And if we simplify this, then we get minus 4k minus 4 is equal to 3k minus 6, and it implies 7k is equal to 2, and it implies k is to 1 is equal to 2 into 7. So you can check the y coordinate also. So you can check for the y coordinates also. So the point minus 4,6 divides the line segment joining the points A minus 6, 10 and B 3, minus 8 in the ratio 2 is to 7. So now note it down. You can also find this ratio by calculating the distances PA and PB and taking their ratios, provided you know that A, P and B are collinear. Okay, so you can also find this ratio by calculating the distances PA and PB and taking their ratios, provided you know that A, P and B are collinear. So now we discuss this example. So in this example, we have to find the coordinates of the point of trisection, that is point divided in 3 equal parts of the line segment joining the points A 2, minus 2 and B minus 7, 4. So let us solve this example. So here we let P and Q be the points of trisection of AB. That is AP, PQ and QB that are equal. So AP is equal to PQ is equal to QP. So you can see in this figure, AP is equal to PQ is equal to QP. And therefore P divides AB internally in the ratio 1 is to 2, and therefore the coordinates of P by applying the section formula are 1 into minus 7 plus 2 into 2 divided by 1 plus 2, comma 1 into 4 plus 2 into minus 2 divided by 1 plus 2, and that is minus 1, 0. Okay, so now Q also divides AB internally in the ratio 2 is to 1, and so now we can use the section formula. So the coordinates of Q are 2 into minus 7 plus 1 is to 2 by 2 plus 1, comma 2 into 4 plus 1 is to 1 into minus 2 divided by 2 plus 1, that is minus 4, 2. So therefore the coordinates of the points of trisection of the line segment joining A and B are minus 1, 0 and minus 4, 2. Okay, and here we note it down. We could also have obtained Q by noting that it is the midpoint of the line segment PB. So we could have obtained its coordinates using the midpoint formula. Okay, so here in this example, find the ratio in which the y-axis divides the line segment joining the points 5, minus 6 and minus 1, minus 4. Also find the points of intersection. Okay, so here let the ratio be k is to 1, then by the section formula the coordinates of the point which divides EB in the ratio k is to 1 are minus k plus 5 divided by k plus 1, minus 4k minus 6 divided by k plus 1. Okay, and this point lies on the y-axis. So we know that the y-axis, for the y-axis abscissa is 0. So here minus k plus 5 by k plus 1 is equal to 0. Okay, so here we get the value of k is equal to 5. So that is the ratio is 5 is to 1, and putting the value of k is equal to 5, we get the point of intersection as 0, minus 13 by 3. So I am giving this example as your homework problem. Okay, so I am giving this example as your homework problem. So I stop here this lecture. Thank you very much to all of you.